Okay, today's just a continuation of what we did yesterday, graphing with slant asymptotes and also having holes in the graph. The additional thing for today is coming up with the equations from the graph. So looking at number 1, what is the very first thing we need to do? Factor. So notice for the numerator it has a GCF, which is x. So factor out the GCF. Inside the parentheses we would have x squared plus x minus 6. The denominator, what two numbers multiply to -2 and add to +1?
Plus 2.
Positive
2.
2 and
X minus 1.
x minus 1. Now, in the numerator, that trinomial is factored. So what two numbers multiply to -6 and add to +1? Positive 3 and -2. And do we have any factors that cancel? No, we don't. So what does that tell me? No holes. So we're using holes, put no solution. So our domain is going to be all real numbers except x cannot be. What values would make that denominator equal 0? What values would make the denominator equal 0? -2 and +1. So the vertical asymptotes are x equals -2 and x equals +1. For the horizontal asymptote, where's the higher degree? Top or bottom? Top. So if it's top heavy, what do we know about the horizontal asymptote? There's not one. So if there's not a horizontal asymptote, what does that tell us? There is a slant asymptote, and how do I find the slant asymptote? Divide. We need to do long division. So inside we'll have x cubed plus x squared minus 6x. That needs to be divided by x squared plus x minus 2. Now again, the trick with long division is make sure you look at the first term. So the first term for this one is x squared. First term for that one is x cubed. First thing I'm going to put is y equals over the first term. And looking at the first term, so we multiply x squared by to get x cubed. X. Now, outside values get multiplied. So this trinomial needs to be multiplied by x. So what's x times x squared? X cubed. And x times x is x squared. And x times -2, -2x. So all three of those need to be subtracted. But for our purposes, how many terms have to cancel until we're finished? 2 terms. So what happens with the x cubed when we subtract them? They cancel. What happens with the x squared when they are subtracted? They cancel. So if I have 2 terms canceled out, I'm finished. So what is the slant asymptote? Y equals x. Make sure you have the y equals. Now for the x-intercept, how do you find the x-intercept? Set the numerator equal to 0. I'll use the factor form, so we have x plus 3, and x minus 2. So how many x-intercepts do we have? 3. So for x, what is the x-intercept for that one? 0. What are the other 2 x-intercepts? -3 and? Oh, what? Oh, no, not 6. Make sure we're using the simplified version. So you use the simplified numerator. So using the simplified numerator, it's 0. This one was -3, and for that last one, it's +2. And the y-intercept, how do you find the y-intercept? Put 0 for x. So I put a 0 here, 0 here, 0 here. So that would be 0 over -2, which would be 0. Yes.
Wouldn't be x plus 3, x minus 3, x minus 2, x plus 2.
Let's see if we did. Okay, so now that we have all the information gathered, go ahead and the first thing you need to do is plot those asymptotes. So we have vertical asymptotes at -2. And +1. And we have a plane asymptote that is a linear parent function. And you can start with a y-intercept of 0, go over 1, up 1. Or if you're very familiar with it, and you should be, you should know that it just cuts quadrants 1 and 3 right down the middle. So asymptotes first. After the asymptote, plot your intercepts. So we have 3 x-intercepts to plot. So we have one at 0, which is right there on the slant asymptote. We have one at -3. And we have one at +2. And the y-intercept is already plotted with the x-intercept. So 0, 0 is a common point between the x and y-intercept. So now we have to figure out what's happening between the vertical asymptote, what's happening over here to the left of x equals -2, what's happening to the right of x equals 1. So let's go ahead and start kind of in the middle right here, so we can figure out if it's a cubic or quadratic. So that first x value we need to use would be -1. So we need to find f of -1. Now, when you are substituting in, if nothing canceled out, then you could either use the original equation or you could use the factored equation. Which one do you want to use, original equation or factored? Factored. Okay, so if I use the factored form, that's this one right here. So for x, this would be -1. And then for x plus 3 would be -1 plus 3. And for x minus 2, it would be -1 minus 2. And in the denominator, we would have -1 plus 2 and -1 minus 1. So we have the -1. What's -1 plus 3? 2. What's -1 minus 2? -3. -1 plus 2? 1. And -1 minus 1? -2. So when we multiply those, -1 times 2 times -3 causes 6 over -2. So what would that ordered pair be? -1, -3. Let's go ahead and plot that point. So -1, -3, down here in quadrant 3. Now, I have to decide if they're going to be cubic or quadratic. Do I have enough information to decide? No, I need one more point. I need to know what's happening between 0 and 1. Well, probably the easiest would be f of 1/2. Not going to be fun, but we can do that one. Okay, so for 1/2, this would be 1/2. And then 1/2 plus 3. 1/2 minus 2. 1/2 plus 2. And 1/2 minus 1. So we'll have the 1/2. 3 would be 6/2, so 1/2 plus 6/2 would be 7/2. 2 would be 4/2, so 1/2 minus 4/2 would be -3/2. And 1/2 plus 4/2 would be 9/2. And 1/2 minus 2/2 would be -1/2. I'm going to go ahead and do a little bit of canceling. What do you notice that we have in the same? Top and bottom. 1/2 and 1/2. So keep the negative. So when I multiply these, 7 times -3 is -21. 2 times 2 is 4. And down here we have -5/2. And when you divide by that fraction, multiply by the reciprocal. So 2 and 4 have a common factor of 2. So that gives us negative 21 over negative 10, which is equal to what? 2 and 1/10 or 2.1, either one. So that ordered pair would be 1/2, 2.1. So 1/2, 2.1, plot that point. 1/2, 2.1 would be right here. So what type of function do we have between those vertical asymptotes? Cubic. So go ahead and connect those points with a cubic function. And now we already have points over here between the slant asymptote and the vertical asymptote. So we need a few additional points to figure out exactly how much does it curve. We already have negative 3. What's the number smaller than negative 3 you'd like to use? Let's do negative 6. So f of negative 6 would be negative 6. Negative 6 plus 3. Negative 6 minus 2. Negative 6 plus 2. Negative 6 minus 10. That gives us negative 6. What's negative 6 plus 3? Negative 3 was negative 6 minus 2. Negative 8. Negative 6 plus 2. Negative 4. And negative 6 minus 1. Negative 7. I'm going to do a little bit of dividing. What's negative 8 divided by negative 4? 2. 2 over 1. That'll make it a little bit better. And what's negative 6 times negative 3? 18 times 2? 36. And what's 1 times negative 7? Negative 7. So that ordered pair, the x value is negative 6. The y value is also negative. And how many times does 7 go into 36? 5 times. So how many left over? 1/7. Let's plot that point. Negative 6. Negative 5 and 1/7. Is that enough to where I can tell what's happening?
Yes.
What's happening?
Curving.
It's curving. So it's going to curve between the slant asymptote and that vertical asymptote. Now we need to finish this out. We have an x value of 2. We need something bigger than 2, so what x value would you like? 4? Or 6?
6.
6. Let's see what's happening further out. That way we won't have to do this so many. So this would be 6 times 6 plus 3. 6 minus 2. 6 plus 2. And 6 minus 1. So this would be 6. 6 plus 3 is 6 minus 2. 6 plus 2.
8.
6 minus 1. 5. Let's see, 4 over 8, what does that reduce to? 1/2. And that'll be a little bit better for us. So what's 6 times 9? 54.
Oh, yeah, 54. Okay.
And 2 times 5?
10.
10. And 54 divided by 10?
6, 4, 10.
5.4. Or 5 and 4 tenths. So that would be 6. 5.4. Okay, plot that point. 6, 5.4. 6, 5.4. That right here. Can I tell what's happening?
Yes.
Yes, what's happening? It's curving between that vertical asymptote and the slant asymptote. Okay, questions on number 1. Moving on. Next one, what's the first thing we should do? Factor. So x minus 1 is not factor. But x squared minus 4, what is that called? Difference of squares will have x plus 2, x minus 2. Do we have any factors I can't do? No, so what does that tell me? No hole, so put a hole but no solution. So our domain is all real numbers except x cannot equal what numbers? Plus or minus 2, so those are the vertical asymptotes, x equals plus or minus 2. Horizontal asymptote, is it top heavy, bottom heavy, or equal? If it's bottom heavy, what's the horizontal asymptote? Y equals 0. If you have a horizontal asymptote, there's not a slant asymptote, so woo-hoo, no division there. If I want the x-intercept, how do I find the x-intercept? Set what equal to 0? Set the numerator equal to 0. So when I set the numerator equal to 0, what is that x-intercept? X equals positive 1. And for the y-intercept, how do you find y-intercept? Plug in zeros for x, so put a 0 here, a 0 here. That gives us negative 1 over negative 4, which is equal to? Positive 1, 4. After you've answered all those questions, next step is plot the asymptote. So we have two. Huh?
How do you get the y-intercept?
You get the y-intercept by putting in a 0 for x. So I put a 0 right here and a 0 right here. Okay, so the asymptote. We have vertical asymptote at negative 2. We have a vertical asymptote at positive 2. So between these asymptotes, it's either quadratic or cubic. No slant asymptote, but we do have a horizontal asymptote on the x-axis at y equals 0. The other one's bottom heavy. After you plot your asymptotes, the next step is plot your hole and plot your intercept. So did we have a hole here? No, but if you did, make sure you put an open circle for it. But plot your x-intercept. So we have an x-intercept of positive 1. And we have a y-intercept of 1/4. And now we have to figure out, in between the vertical asymptotes, is that going to be quadratic or cubic? Right now, do I have enough points to know? No. So I'm going to have to use one of those values. Which one do you want to do? Negative 1. So we need to find f of negative 1. Now, again, when you are trying to evaluate, you can, if nothing cancels, you can use either the original equation or the factored one. Here, I think the original equation would be faster. So this would be negative 1 minus 1. And in the denominator is negative 1 squared minus 4. Okay, so what's negative 1 minus 1? Negative 2. What's negative 1 squared? And 1 minus 4? Negative 3. So that ordered pair would be negative 1, and the y value is 2/3. Negative 1, positive 2/3. Plot that point. Negative 1, positive 2/3. Looking at those points, is it quadratic or cubic? Cubic. Left arm points up, right arm points down. Now we have to figure out what's happening over here on the left side. So what x values would you like to substitute in?
3.
Negative 3.
Oh.
So let's do f of negative 3. That would be negative 3 minus 1. Negative 3 squared minus 4. What's negative 3 minus 1? Negative 4. What's negative 3 squared? 9 minus 4? 5. So that ordered pair would be negative 3, negative 4/5. And let's do another one. What do you want to do still on the negative side?
Negative 5.
Negative 5. So for f of negative 5, that would be negative 5 minus 1, negative 5 squared minus 4. What's negative 5 minus 1? Negative 5 squared? 25 minus 4? 21. So that order pair would be negative 5 with the x value, And negative 6 over 21 simplifies to
Negative 2/7.
negative 2/7. Let's see if that's enough points for us to be able to tell what's happening. So let's plot those 2 points. We have negative 3, negative 4/5, and we got negative 5, negative 2/7. What do you think's happening? Curving between the horizontal asymptote and vertical. So let's go ahead and curve it. Now we have to figure out what's happening to the right of x equals positive 2. So now give me 2 positive x values bigger than 2. 3 and what else?
6.
3 and 6. Sounds good. So let's do f of 3. And then we'll do f of 6. So for 3, this would be 3 minus 1. And we'll have 3 squared minus 4 in the denominator. What's 3 minus 1?
2.
9 minus 4?
5.
5. So that order pair would be 3, 2/5. And for 6, this would be 6 minus 1 over 6 squared minus 4. 6 minus 1 is 5. 6 squared is
36.
36 minus 4,
32.
32. So that word pair would be 6, 5 32. Okay, so plot those points. So we have 3 and 2/5 is 0.4 as a decimal. And that was 6, 5 32. Can you tell what's happening over there?
No. Oh, doesn't. Yeah.
Yeah, it's going to do what?
Curve.
Curve, and it's going to curve between the vertical asymptote. And we saw that over here, they're getting closer and closer to that horizontal asymptote. Okay, so that is a review, that's a refresher, that's what we did yesterday. Now, the last 3 questions, and you will have some like this on your test, as well as on your assignment today. Now we're going backwards. Now we're given the graph. Now we have to come up with a functional equation. Okay, so the first thing we need to do is fill in the requested information. The first one is the x-intercept. So the x-intercept is what?
Negative 2.
-2. So x equals -2. What is the y-intercept?
2.
Positive 2. Vertical asymptote is x equals what?
Negative 1.
-1. And there's that vertical asymptote right there. Now what's the horizontal asymptote?
1.
Y equals 1. Do we have a plain asymptote?
No.
But no solutions, only the blank. And a hole on these, a hole will look like a place that's been erased, or an open circle. Do you see an open circle or a place where it looks like the graph has been erased? No. So we don't have any holes. Okay, where it says function, on your assignment, yours will say f of x equals. So just keep that in mind. This is a functional equation. On your assignment, it will say f of x equals. So now what we need to do is we need to write our functional equation in factors form. So start with your x-intercept. Tell me this. How do you find the x-intercept? You set what equal to 0? You set the numerator equal to 0, right? So if I set the numerator equal to 0, that means my x-intercept has to be at the top of the fraction. But if that's the answer, how would I write -2 in factor form? X plus 2. So your x-intercepts, factor them, they go in the numerator. What about vertical asymptotes? How do we find vertical asymptotes? Set the denominator equal to 0. So your vertical asymptote need to go to the bottom. So if the vertical asymptote is -1, what would that look like in factor form? +1. Okay, so we took care of the x-intercept. So x-intercepts, factor them, they go in the numerator. Vertical asymptotes, factor them, they go in the denominator. We don't have any holes, so we don't have to worry about that. But what we need to do is check the horizontal asymptote. So your horizontal asymptote can either be none, y equals 0, or y equals a constant. Notice our horizontal asymptote is y equals a constant. So if it equals a constant, what does that tell me? Yeah, that means the degrees are the same. Well, are the degrees the same? And are the ratio of the coefficients 1 over 1?
Yes.
Yes. So the horizontal asymptote took care of itself already, but you still need to check that because it doesn't always take care of itself. And the last thing you need to check is the y-intercept. And for the y-intercept, how do you find y-intercept? So if I put 0 for x, what does that give me? 2 over 1, so the y-intercept is correct. So make sure this is the fraction bar. So you need to have the factors of the x-intercept up top, factors of the vertical asymptote in the bottom. Next one, problem 4. X-intercept. What are the x-intercepts? -2 and +2, so I'm going to put plus or minus 2. What about the vertical asymptote?
0.
X equals 0. So what's the y-intercept? There's not one because that's the asymptote. Does this one have a horizontal asymptote?
No.
No, because it has what? Slant asymptote. So we need to write the linear equation for that slant asymptote. Notice it starts at 0 and the slope is what? 1, so that would be y equals x. That's the linear parent function. And the whole. Do you see a place where it looks like it's been erased or an open circle? So we don't have any holes to worry about. Now for the function, again on your assignment, it will be f of x equals, and then you'll have to write your answer in factors form. Yes, you could write it in polynomial form, but that's extra work, okay? So either one would be fine, but factors form is less work for you. Okay, so what do I do with my x-intercept? Factor them and put them in the top. So what would by 2 factors be for the numerator? X minus 2 and x plus 2. Doesn't matter which one goes first. No, it doesn't matter which one goes first because we're multiplying, and multiplying is commutative. It doesn't matter which one's first. What do I do with my vertical asymptote? So I took care of the x-intercept. Where does the vertical asymptote go? Yeah, in the bottom. So how would I write 0 in factor form? Just be x. So we took care of the vertical asymptote. We don't have a hole, so we don't have to worry about that. The next thing you need to check is your horizontal asymptote. So our horizontal asymptote is none, and what does that tell me? It's top heavy. So if it's top heavy, I need to check it. Is this one top heavy? Yeah, because x times x will give me x squared. If you want to do the slant asymptote, you could do the polynomial long division, but it's taken care of. Now for the y-intercept, go ahead and check that. How do you find y-intercept? And what happens if I put a 0 for x right here? I would be dividing by 0, and can you divide by 0? No, that would be undefined, so we're good. Okay, I want you to do number 5, fill in the information, or let's fill in the information together to make sure it's right. So number 5 is different. How's it different? It does have a hole. So if you want to put an open circle, that's the part I was talking about. If you see a part of the graph where it looks like it's been erased, that's where you have a hole. So our hole is going to be at -1, +1. What are the x-intercepts? -3 and +2. What about a y-intercept? None. What about vertical asymptote? X equals 0 and 5. I'll just put 0, 5. We got 2 of them. And what about the horizontal asymptote? Y equals -2. Do we have a slant asymptote? No. Okay, I want you to go ahead and start writing that function. Just put everything we've done so far. So take care of your x-intercept, take care of your vertical asymptote, and we'll talk about what you'll have to do for that hole here in a minute. Okay, for the x-intercepts, factor those x-intercepts, and where do they go? Top. So what's the two factors for the x-intercept?
X plus 2,
X plus 3, x minus 2, doesn't matter which one went first. No. For the vertical asymptotes, when you factor them, where do they go? Bottom. So for 0, how would I factor 0? X, and how do I factor 5? X minus 5. The hole. Now that's the new part for the hole. How do I know I have a hole? The factor cancels from both the top and the bottom. So here you have to just look at the x value. So if the x value is -1, what would the factor be? X plus 1. So in order to have the hole, it has to cancel, which means we have to have it in both the top and the bottom. So if you have a hole, make sure you factor the x value, and it needs to go in the top and the bottom. And now horizontal asymptotes, what do I know? Was this top heavy, bottom heavy, or equal? Equal. Well, let's check it. X times x would give me x cubed, and down here x times x would give me x cubed. Does that give me y equals -2? What does that tell me about this top one? This top one would have to be -2. So all you have to do to fix that is put a -2 out front. If this were like a 2/3, then you put a 2 in the top, 3 in the bottom. So this is just -2 over there. And we don't have to worry about the y-intercept, line asymptote, so care of itself.